All right, hello, lovely Year 12 students. Looking at the last topic here, 5e, distance from a point to a line. We're going to be doing this in 3D. I'm just going to jump straight to an example, which will sort of show us how to do this here. So what we've got first up is we've got three particular points. I'm just going to draw them first up here. So let's just say we've got point. So we've got point A exists here. Let's just go right here. We've got point B up here. I've got point C here. Actually, it's going to go back. Let's just say C exists over here. That's going to draw a line connecting each of these points. So line to B to C to A. This is our origin. And actually, I might go list each of the positions as well for each of these ones here. So for A, we've got 3 minus 1, 2. For B, we've got 2, 3, negative 1. And for C, we've got 1, negative 1, 1. So we've got each of our points there. And we're told that BC forms a line. So basically, I'm just going to draw a line going through BC like so. And we want to know the distance from point A to that line. So that's just going to be the shortest distance here. And that would make a right angle triangle there. So we're thinking, how do we figure out that distance? This is what we're trying to figure out. Let's call that point D there. So how do I figure out the line AD? Well, I can create a line with BC because I've got those 2 points there, so that's easy enough. And then if I can come up with a line AD, then if I do the dot product between those two, it should equal to 0. And that's essentially how we're going to solve this problem here. So let's do BC first up. So let's go. All right, my line BC is equal to. So let's just draw out to go from B to C. So we're going negative B plus C. So that's what we're doing there. We're going to go minus B plus C, and I'll write it out properly. So do minus OB plus OC. So that's just going to be minus 2, 3, negative 1 plus OC 1, negative 1, 1. What does that give us? That gives us negative 1 minus 4 and positive 2 for that there. Okay, so we've done those ones there. Now, next I want to figure out, well, how do I get from A to D? I want to go from A to D. Let's draw a path to see where we're going. So to go in that direction there, well, I don't know what that is, but I can go AO, I can go OB, and then some scalar amount of BC, that's going to get me all the way over there to D. So let's go do that now. So that's going to be, I'll come back to this different color. So that's just going to be minus OA plus OB plus some lambda amount of BC. Okay, let's do that. So that's going to be negative of 3, negative 1, 2 plus OB 2, 3, negative 1 plus some scalar amount of our solution up here. So negative 1 minus 4, 2. Cool. Let's simplify. That is going to give us, all right, neg 1, take lambda. 1 plus 3, so 4, take 4 lambda. And then that's going to give us minus 3 plus 2 lambda. Okay, so that's our AD there. All right, so we've got a vector for BC, we've got a vector for AD. Now we can do the dot product. So we know that BC dot AD is going to equal to 0. And the reason for that is we know that that line there and that line there meet at 90 degrees, because that's going to give us that shortest path. So let's go expand that there. Let's go write it out first. So BC was -1, -4, 2. -1 minus 4, 2 dot AD. -1 take lambda, 4 take 4 lambda, minus 3 plus 2 lambda is equal to 0. Okay, and if we go ahead and do that, we're going to get 1 plus lambda, take 16, plus 16 lambda, take 6 plus 4 lambda is equal to 0. Simplify that, 21 lambda, take 21 is equal to 0, so lambda is equal to 1. We're now going to sub that into AD. So what does that give us? Well, AD is now going to be -1, take 1 is going to be -2, 0 and -1. So the absolute value of that 2 squared, 1 squared, 5, so √5 for that there. Okay, so that's one way of going ahead to do it. I'm now going to show you a second way you can achieve this to get the same solution. Now what I'm going to do is I'm actually just going to copy this whole diagram here, because this is going to come in handy. So I've got all that there. I'm going to go copy and come down here and go paste. Oh, there we go. Cool. All right, I'm just going to get a different color. And so we're going to do the exact same thing again. However, we're just going to focus on this particular triangle here. So I'm going to create a right angle triangle here and call this theta there. Okay. Now, what we're trying to find is that distance AD. And we can think, well, all right, let's write out an equation, something that we know that might do it. So I might know that, well, I want to figure out, well, what the magnitude of AD is. That's what I'm trying to find. And just using a basic trig, that's the opposite. AD is the hypotenuse. So AD over CA is sine. So that means if I do CA by sine theta, that'll give me the length of DA. However, I can figure out CA pretty easily. Well, it's just the difference between those two. However, I don't know what theta is. But let's have a think about what I showed you in a few weeks ago. So this is where we're going to use the equation that I showed you about the cross product. So where we know that if we did the cross product of two vectors and we did the absolute value of it, it works out to be the area of a parallelogram, but it works out to be A, B, sine theta. So how can I use this to help me with the one before? Well, I'm going to rewrite out that exact equation as I did before. So I'm just going to have, say, well, okay, AD is equal to CA sine theta. And what I'm going to do is I'm just also going to multiply it. I'm going to multiply that that value by BC as well. So I'm going to multiply it by BC, and I'm also going to divide by BC. So I'm essentially multiply by BC, divide by BC, so it's an equivalent equation. So if I do CA multiplied by BC sine theta divided by BC here. So I just rearranged it. Now if you have a look, you go, oh, actually, that part there is exactly the same as that part there. They're identical. So I'll just underline those ones there. So then I can say, well, if that's the case, I can say that CA BC sine theta is actually really just the magnitude of CA cross BC. And then if I divide that by BC, that'll tell me what the magnitude of AD is. So BC, I can easily identify. I figured that out earlier. CA, I can figure out as well. So let's just write out what those are. So we'll just write, well, BC is equal to -1, -4, 2. CA is equal to 201. So I've got those ones there. Now, when we do the cross product, so if I was to say, okay, what is CA cross BC? That is equal to, well, let's come to the good old class pad here and have a look. So I'm going to go. So what have we got? We've got CA201. And for the other one, we've got -1, -4, 2. And what I want to do is I want to do the cross product. So I'm going to go action vector cross P. There we go. So we've got 4, -5, 8. So I'm going to come back over here and write that in. So we've got here -4, 5, 8. So that means if we go, well, find the absolute value of that. So if I go, well, absolute value of -4, 5, 8 divided by BC, absolute value of that. So -1 -4, 2. That'll give me my distance AD. So I can come back to the class pad and I'm going to go back over here and I'm going to go action vector norm divided by action vector norm. I'll put in that one there. All right, so it's going to figure out, so norm is going to do the magnitude for me. And so the two were -4, 5, 8 divided by -1, -4, 2. Let's see what it does. Oh, look at that. How cool is that? Root 5, same answer as before. Cool. So come here and go equals to square root of 5, our same solution as what we got before. So this particular method here, I can't really think of a scenario where you'll actually need to use it, but it's just so you're aware that there is an alternative way of getting there, but it's not an intuitive way of thinking about it. However, very simple way of doing it, come up with two vectors and then knowing that, well, the shortest distance means that they're going to meet perpendicular to one another, and so you're just doing the dot product and it's going to equal to 0. Solve for lambda and then state your solution. Alrighty guys, hope you enjoyed.